Okay, in this part of the integration, we are breaking down a huge fraction first. We break a huge fraction into partial fraction, then we integrate. Okay, so this one is not like a reverse idea. Okay, we don't have quotient rule in integration. That's why if we got a huge fraction, it's not possible for us to integrate using any equivalent of a quotient rule. So this is not the reverse idea. This is like we break a big fraction into a smaller one so that it can match back into any of our previous integration formula. So again, I will not be focusing on the partial fraction thing. So for example, in part one, in part one, this is under case one of partial fraction. If you forgot, how do you do partial fraction? Okay, so you let me know. Okay, I show you the video for case one where the denominator are linear. How do you break it into partial fraction? Okay, so I will not show the steps. Okay, you gotta give it a try. Okay, nothing goes wrong, you will get something like this. So to you, right, you must be able to see that this big fraction is actually equivalent to two small little fraction. Okay, so it's not a case of reverse when we do the hence part. So when we do the hence part, we see it as the huge fraction is an equivalent of two little fraction. So since I don't have a quotient rule to integrate, I'm going to change up the big fraction. So integrating a big fraction is equivalent to integrating the two partial fractions. So it's like replacing the whole big fraction with two little fraction. So it's not possible for us to integrate that huge fraction, but we change it to the two small little one, then I can integrate. So how am I supposed to integrate? I can split it into two. I can split it into two. So if I got two small fraction, that means I can split into two integration. And hopefully you recognize this one. Okay, do you remember this? This one you did it in integrate the second teaching worksheet. So here it will be 1 over a ln ax plus b. So I'm applying exactly this onto this formula. So this formula require my numerator to be 1. So I'll manipulate out the numerator first. Then I'm going to apply the formula. So both integration use the same formula. So you should have practiced this part in the previous teaching worksheet first. So this is what I gotten. Okay, so we replace it. So this one is not a reverse. This one is not a reverse. We replace the big thing with the equivalent of two little fraction. Okay, then we apply the formula accordingly. So if let's say your partial fraction, you can't remember, you got to recap this. In a very simple case, during O-level, this kind is worth 8 to 10 marks. Because partial fraction itself is already 4 marks. Integration like this, it could be another 4 marks. So usually it's quite marks expensive. Okay, so the next example is what we call case 2 partial frac. Okay, so the next example is a case 2 partial frac. So if you need to recap, how does case 2 partial frac works? Okay, I can separately show you the video, then you can try to see whether you can get the correct A, B, C or not. So this is under case 2. I will not be showing you how to get A, B, C. Okay, so that's a separate situation. So it's more like you compare the numerator to get the identities. So if nothing goes wrong, you will get something like this. So the huge fraction that you couldn't integrate is actually equivalent to 3-liter fraction. So you replace it totally. So replace it with the 3-liter fraction. And because if you replace it with the 3-liter fraction, you can split into 3 different integration. So you can split into 3 integration. And the first two is actually the ln differentiation. So you just organize it in such a way that the numerator is 1. But the last one is not. The last one is your basic formula. The formula where you got to return a power, divide by new power. So sometimes some students will forget that they can actually use that formula. So you return the power, divide by new power. So all in all, you will be getting something like this. So all these require your basic formula, the formula that you learn in integration 1 and integration 2. Okay, so again, I need to emphasize in example 4 and example 5, we break a huge fraction into a smaller one, and we replace a huge fraction so that our integration becomes easier. So in this situation, we are not doing the reverse, not like we are undifferentiated. It's different from example 1 to 3.